Reynolds number is the dimensionless Here, you can see the Reynolds number formula on the left and the variables and their meanings on the right. There are three types of fluid flow. There is laminar, transitional, and turbulent. Here, you can see laminar. Laminar flow is as if two sheets of fluids are passing over each other, where the fluids do not mix, and you have a thin stream line of one fluid flowing through another. On the top, you can see a live video of our experiment, and on the bottom, an example of this flow. Next up is transitional flow. This flow is when the two liquids start colliding with each other, and it's a little bit more wavy, where the fluids are more viscous or the flow is higher, causing more turbulent. Up at the top, you can see our video demonstrating the transitional flow, and then on the bottom, the example of what it's like. Lastly, turbulent flow. Turbulent flow is whenever two fluids are moving fastly through each other and or whenever they have low viscosity. Fluids will tend to fractal and break apart in the middle of it, as you can see in the bottom. And up at the top, we have our experimental video showing turbulent flow. The bill of materials for our project was one large plastic container, one small plastic container, 3/8 inch outer diameter silicone tubing, 2-inch outer diameter acrylic tube, 3/8 inch outer diameter tubing ball valve, a 1-inch ball valve, 1-inch 90-degree elbow, a 3D printed funnel, 3D printed 16 gauge needle, or 0.264 inches outer diameter of the needle, water, food coloring, 3-liter bucket, stopwatch, and 1 PVC pipe. The total cost of the apparatus was $119.60, with the total cost of the experiment being $130. This is the setup for our experiment, and as you can see from left to right, there is a 2-inch acrylic tubing with a small collection point at the end, our large container of 27 gallons to show the fluid flow, and on the right, a 9-gallon container containing the food coloring so you can see the different types of flow. So here is the example video of our experiment conducting the laminar flow experiment. As you can see, the inside, where the needle is, has a straight, thin line showing that the flow is laminar. And on the outside, with the acrylic tubing, you can see how that flow continues to go through and stays relatively collected as it passes through the clear tubing. Here we have the experiment for the transitional flow. As you can see, the liquid starts to separate in the center as it is below the 4,000 for the Reynolds number. When it gets to the acrylic tubing, you can see that this flow doesn't fully separate and is still wavy and mostly collected together, but is still transitioning between the turbulent flow and the laminar flow. Finally, you can see our experiment for turbulent flow. As you can see, the video is showing that the fluid is much faster than the other two, and it is separating inside the portion just after the needle. And once it reaches the clear acrylic tube, you can see that most of it has spread out and is dissipated as it is mixing together more evenly than the previous types of flow. Here, we are moving on to our calculations. Up at the top, you can see the important formulas that we use to calculate these values. And in the middle and below, you can see the variables that we had included. For laminar flow, our first trial took 168 seconds, and the values for Reynolds is 577. For trial 2, it was 175, with its value being 554. Trial 3 was 182 seconds, with the Reynolds number being 535, with the average of the Reynolds number averaging out to 555. For transitional flow, the trial time took 41 seconds, with the Reynolds number coming out to 2,343. Trial 2 took 39 seconds, with the Reynolds number coming out at 2,451. Trial 3 was 38 seconds, with a Reynolds number of 2,539, with the average Reynolds number being 2,444. And for turbulent flow, Trial 1 was 22 seconds, with a Reynolds number of 4,297. Trial 2 was 21 seconds, with the Reynolds number of 4,396. And Trial 3 was 23 seconds, with a Reynolds number of 4,149, with an average of 4,281.